Hello, class 9 students of ICSE. We are going to start the class 9 journey with the chapter, The Study of Gas Laws. Now, all of you might be wondering why I'm not studying with the periodic table or any other chapter which are in the first, and study of gas laws are actually comes at the end of the book. Why I'm starting with this chapter? Because this chapter is very easy and it's basically a one-liner topic. Okay, so let us go to the line which will complete 95% of these gas laws. So the line is Charles. Charles is working. Charles is working under pressure. Charles is working under pressure. Amantons. Amanton is measuring. Amanton is measuring volume for boil to make tea. Okay, so this is the line which actually completes 95% of this chapter, the study of gas laws. Now, Charles will be actually Charles' law. Okay, here Charles will be Charles' law. Now, as Charles is working under pressure, so in Charles' law, pressure must be constant. Okay, so in Charles' law, pressure should always, if we come across a question, which we will going to discuss in a few while, if you come around a question where it is said that the pressure will remain constant, then by closing your eyes, you have to follow that this question will be solved with the help of Charles' law. Now, what is Charles' law? When the pressure is constant, the two other variables that remains are volume and temperature. Volume and the temperature are the two other variables that will be there when the pressure will be kept constant. Now, volume and temperature has a direct relation to each other, and this form will give you this equation, this relation in Charles' law. Okay, V1 by T1 equals to V2 by T2. Now, Amanton. I know most of you haven't heard of this Amanton's law, or will not heard, or will not be able to learn the name of Amanton. Actually, Amanton and Gay-Lussac's are the same name given in the internet also, but Amanton's law actually states that the volume is constant. Okay, volume will be kept constant because Amanton's was measuring volume, so volume will constant. The two other variables that will be there are pressure and temperature. The two other variables are pressure and temperature. So here the relation will be P1 by T1 is equals to P2 by T2. That means pressure has a direct relation, or pressure is directly proportional to temperature. Now, last one, Boyle's law. Boyle's law is very interesting, and actually most question comes from this law. Here, T, Boyle will be making tea. Amanton's is measuring volume for the Boyle to make tea. Now, when Boyle will be making tea, that means here temperature will be constant. Temperature will be constant. Okay, so but pressure and volume has a means they are not directly proportional, they are inversely proportional to each other. So here you will write P1 V1 is equals to P2 V2. Now let's come again. Charles' law means volume is directly proportional to temperature. Amanton's law means pressure is directly proportional to temperature, and Boyle's law means pressure is inversely proportional to volume. Okay, so these are the few things. So whenever you are going to draw a graph, volume and temperature in X or Y, anywhere you can put anyone, so you will get a straight line. Similarly, pressure and temperature, this graph will also give you a straight line. Okay, pressure and temperature will also give you a straight line because they are directly proportional to each other. In here, if you draw pressure and volume. Now with increase in pressure, volume decreases. So you will have a graph like this. If you draw a graph with pressure and 1 by V, then you will get a straight line. So these are the few things. Now let us come to few numericals. If you have understood this, one line and everything is up. Now let us come to numericals. Now we have a book of ICSE, Simplified Chemistry, that most of the people follow. Let us see what is it. We will solve 4 questions today. Okay, and I think 4 questions is enough to understand all the parts of the study of gas laws. Now, let's just start. So let us start with the question number 1. What volume of gas occupies 740 millimeter pressure, which at 1480 millimeter occupies 500 cc? Okay, temperature being constant, as it has been stated that temperature will be constant. Temperature constant. That means which law? It means Boyle's law should be followed. Boyle's law should be followed. What is Boyle's law? P1 V1 is equals to P2 V2. P1 V1 is equals to P2 V2. This is Boyle's law. One more thing, let us first complete it. So P1 is 740 millimeter of mercury, okay, which occupies, I think, how much what is given? 740 millimeters. So you have to find the volume here. Means you have to find the V1 here, which at 1480 millimeter of pressure occupies 500 cc. So millimeter will it cancel. 740 will be time 1480 will be times 2 of 740. So V1 will be 1000 cc. So it's pretty simple. Okay, now before going to the other questions, I need to mention one thing, that in gas laws, there is a statement, means there is also some standards to be taken, which is known as standard temperature and pressure. Okay, this is an STP, important thing, and it has to be kept, means at a standard state. What should a standard state look like? A standard person, any standard thing, like in class 10, you will be in class 10, you will be learning about standard pH scales. Okay, so here the standards states are measured in terms of temperature and pressure. So at standard temperature and pressure, STP, the temperature is always 0 degrees Celsius, and this Celsius should be converted to Kelvin. 0 degrees Celsius, anything, whenever you are going to convert it to Kelvin from Celsius, so you just have to add 273. If you add 273, you will get Kelvin. So you will get 273 Kelvin. 0 degrees Celsius or 273 Kelvin is the temperature at STP. Now pressure. Pressure is 1 atmospheric pressure. Okay, sometimes it is referred to as 1 bar as well. Now 1 atmospheric pressure has 760 millimeter of mercury, or if you want to convert it to 76 centimeters, it will be 76 centimeter of mercury. Okay, so pressure is 76 centimeter and temperature is 273 Kelvin. If you have 1 mole of a substance, if you have 1 mole of any gas, okay, 1 mole of any gas, at STP, it occupies 22.4 liters. At STP, it always occurs 1 mole of any gas. Now, what is mole? We will come to this concept of mole later on in our class 10. But for now, 1 mole is a quantification of a huge number. Okay, suppose the numbers means a lot of molecules, a lot of atoms come together to make a mole of a compound. Okay, we will learn it in class 10. Not now. This is just for concept that I'm sharing with you. Let us go to the second question. Let us do the third question from here. So let us read the third question. A fixed mass of a gas has a volume of 70750 cc at negative. This is negative. Okay, negative 23 degrees Celsius and 800 millimeter pressure. Calculate the pressure for which the volume will be 720 cc, temperature being negative 3 degrees Celsius. Now, see, here it is said that neither volume is constant, nor temperature is constant, neither pressure is constant. So 3 entities are not inconstant, means they are not constant here. Okay, they are not constant. So what will you do? You will follow the gas law. Okay, you will follow the gas law here, which states P1 V1 by T1 is equals to P2 V2 by T2. It states P1 V1 by T1 is equals to P2 V2 by T2. Understood? This is what your gas law states. Now, P1 V1 by T1 equals to P2 V2 by T2. Let us go to the question again. So what is it said? It said that it is 750 millimeter of mercury. Sorry, 750 cc. Temperature is negative 23 degrees Celsius. So as it is P1, we don't know. V1 is 750 cc and T1 is negative 23 degrees Celsius. It means you just have to add 273 to it to get the Kelvin temperature, or 250 Kelvin temperature is your initial temperature. Okay, 250 is the initial temperature. Now, P1 is also given here as 800 millimeter of mercury. P1 is also given as 800 millimeter of mercury. Now, what is P2? Given P2. Okay, P2 is not given, that you have to find out. Just go and go to the question. You have to find that, calculate the pressure. Means P2 you have to find out. Volume V2 is 720 and temperature is negative 3 degrees Celsius. So P2 you have to find out. V2 is 720 cc and T2 is minus 3 degrees Celsius or 270 Kelvin. Okay. So this is what you have to do. Now you have to do P1 V1 by T1. So you have to just put the values in this equation. P1 is 800, V1 is 750, and T1 is 250. Whereas P2, you have to find out V2 is 720 and T2 is 270. This is what you have to find out. You just cancel out the zeros. 25 times 3 will give you 75. Now, P2 will be 800 times 3 times 270 over 720. Now, 3, if you divide this, you have 800, you can cut 1 0 and not like this. Okay. Final 0 should be cut like this. Now, 8 tens are 80 and 8 nines are 72. 3 threes are 9. 3 nines are 27 and 3 nineties are 270. So it will be 900 millimeter of mercury. Okay, so this is your final pressure, 900 millimeter of mercury. Let's see. Yes, it is given 900. Now let us come to question number 6. Okay, a certain mass of a gas occupied 850 ml at a pressure of 760 millimeter of mercury. On increasing the pressure, it is found that the volume of the gas was 75% of its initial value. Assuming constant temperature, find the final pressure of the gas. Now, in the question, it has stated that you have to assume that, what you have to assume here, temperature is constant. Okay, if the temperature is constant, it will follow which law? Boyle's law. Okay, and Boyle's law states the equation of Boyle's law, P1 V1 is equals to P2 V2. P1 V1 is equals to P2 V2. This is what Boyle's law states. Now, P1. So what was P1? 760 millimeter of mercury. Okay, P1 is 760 millimeter of mercury. 760 millimeter of mercury. And what is V1? That is, I think it was 850. It has given me 850. So it will be 850 ml. Change your m. Okay, no issues. Now you have to find P2 because V2 is 75%. Read the question. Whenever you are doing the question, you have to read it carefully. Here it has said the volume of the gas was 75% of the initial gas. Volume of the gas means on increasing the pressure, it was found that volume of the gas was 75%. So it has not reduced by 75%. It has become 75% of its initial volume. Okay, find the final pressure. Here, if it is found the volume was 75% of its initial value. So if it is 75% of its initial value, so you will write here 75 over 100 times 850, because it is 75% of its initial value. Now you can easily cut 850 from both sides. You will be left with P2 equals to 760 times 100 divided by 75. So just do 4 and 3. So 400, it will be 6, 4, 24, 6, 4, 6, 4, 24, and yes, 2, and 4 7s are 28 plus 2, 30, 3040 over 3, which will result in 1013.33 millimeter of mercury. Okay, I think this is the answer. Yes, this is the answer. Now let us come to question number 8. At a given temperature, the pressure of a gas is reduced to 75%. Again, I'm telling you, you have to read the question carefully. The pressure of a gas reduced to 75%, like this first one. Okay, in the question number 6, it was 75%. Now it is reduced to 75%, means it became 75% of the initial value. Okay, at a given temperature, pressure of a gas reduces to 75% of its initial value and the volume increases by 40%. Now, increases by means you are increasing it 40%. Suppose you have 100 rupees. Okay, suppose 100 pressure is there and 100 volume is there. So, if initial pressure is 100, final pressure will be what? 75. Okay, because it has reduced to 75. So, if 100 is the initial pressure, the final pressure will be 75. If it is X, then it will be 75% of X. Now, if the initial volume is 100, then the final volume will be 140 because it is increased by 40%. So you will write here question number 8, answer number 8. Now, first let us check if there is anything which is constant. Find the final temperature. If the initial temperature was minus 10 degrees Celsius, given temperature is reduced to its initial value, volume increases. So no, nothing constant. So it will follow gas laws. Okay. So as no parameter is set constant, so what will happen? As no parameter is set constant, so we will follow gas law. So we will follow gas law. Okay. So here P1, V1 and T1, this we should write. And here we will write P2, V2 and T2. Okay. P1, V1, T1, P2, V2, T2. So at a given temperature, so the pressure is reduced to 75% of its initial value. So let us take it as X. So it will be 75 by 100 times X. This is Y. This is Y plus 40 over 100, 40% of Y. Okay. Now temperature, initial temperature was T. Let us take T2 will be final time minus 10 degrees Celsius. Sorry. Find its temperature. Initial temperature is minus 10 degrees Celsius. So initial temperature is given here. So we will erase it as minus 10 degrees Celsius. So it will be minus 10 plus 273 kelvins or 263 kelvins. And T2 you have to find out. So this is 140 Y over 100. Now let us put in the value formula. Put these values into this equation. V2 by T2. So P1 is X, V1 is Y, and T1 is 263 kelvins. Okay. P2 is X, will be 75 over 100 times X. times 140 over 100 y divided by T2. Now, just cut the x and y from the both sides. You'll write T2 equals to 75 by 100 times 140 over 100 times 263. Okay, so you will be writing T2 as 75 over 100, 140 over 100 times 263. So you just have to cancel this. It will be 4, it will be 3. Cancel this. So you will have 2 and you will have 7. So 721 and this is 263. So it is an odd number. It will not cut in this fashion. So you will have 3 times 7 times 263 over 2 into 10 means 20. So if you multiply 263 times 21, 3, 6, 2, 6, 12, 2 carry 1, 4 plus 1, 5. So 3, 12, 2 carry 1, 4 plus 1, 5, 5, 5, 2, 3. 5, 5, 2, 3 over 20. So you can write 52.3. If you just cancel this, you will have 552.3 over 2. Now it will be 2, 2s are 4, 1, 5, 15. 2, 7s are 14. 1, 2, 12. 2, 6 are 12. Carry the point here, it will come 3. So 2 1s are 2, 1. So the value will be 276.15. This is T2. So just you have to subtract 273 from here to get it to degrees Celsius or negative. No, it will be 3 degrees Celsius. 3.15 degrees Celsius. 3.15 degrees Celsius. Okay. It is just the conversion of this is Kelvin because this is in Kelvin. So from Kelvin to degrees Celsius, you have to find this. So your final answer is 3.15 degrees Celsius. Let us check. It is 3.15 degrees Celsius. Okay. So this is how you have to do the gas laws. So I think the idea is pretty clear to you all. And thank you for your attention. And we will bring other chapters too. Stay tuned and just wait. We'll come with other chapters and lots of fun. Okay. Bye-bye.